Hello all. In this lecture, we will see about data design process and also we will see an example of a company database. So mainly next topic is to, in the previous lectures we have already seen an introduction to database management softwares. So we have seen different kinds of softwares and all. So next step is to design a database. So initially, when we design this database, so we have to gather the requirements from the customers and all, and we have to draw a conceptual database model. So we have to represent it. So in order to represent that, we have to use entity relationship diagrams. We call it as entity relationship model. So we'll be representing this the requirements in a high level conceptual data model. So that is what we are going to study next. So in this lecture, we will mainly see how to design this database, the basic design database design process, and also we will see an example of company database. So this is the outline. So this is a short lecture on we will see only the basic design of a database system, and also we will see the example that will be followed throughout these lectures. So this is the basic design process. So we have the mini world. So we have already seen what is a mini world. It is a part of the real world. So it can be anything. If you consider this college is a part of mini world, or university, it is a part of mini world, or a company, a particular company is a part of mini world. So from that mini world, we have to gather the requirements collection and analysis needed. So we will gather the requirements from the users or from the various stakeholders. So if we want to develop a college automation software, we have to meet the different people that will be using this software. Mainly, it will be students, the faculty, the parents, like that. There will be many stakeholders who will be using the software. So we will try to interact with them and we will try to gather all the requirements that is needed and we will analyze those requirements. We will analyze those requirements and these requirements can be classified into two functional requirements and data requirements. So there are various methods to collect these requirements in software engineering and all. So mainly, sometimes we will conduct interviews, then we will prepare some questionnaires, or we will do some surveys. Like that, there are different manners to collect requirements, or we can refer some documents that are used in the college. So we know what all things that are to be uh, automated. So by looking into the various documents that the college keeps, so based on that we will be collecting all the requirements and we'll perform an analysis on the requirements and we will fix these are the requirements that will be needed for the software. And from that we'll split the requirements into two. One is functional requirements and this data requirements. This is actually part of software engineering. So traditionally, software engineering and data design had happened in two ways. But nowadays, when UML, Unified Modeling Language, and all, when we use those kind of tools and all, almost these two are combined. But we will see the traditional approach. So we'll split into functional requirements and data requirements. So functional requirements, it actually deals with the functions that the software need to be performed. What all the functions? For example, you need to enter student data. So that is a functional requirement. Or you may have to calculate the grade point, CGPA of a student. Or you want to calculate some average values. Those things come under the soft functional requirements. So those are the functions, those are the main functions that the software should perform. Then there will be data requirements. So in this data requirements, we mainly deal with what all things that are to be stored in the database. So that is the thing we will be focusing on. So we will consider all the data that is to be stored in the database. So that will form the data requirements. All other things will form under the functional requirements. All the interactions with the software, all the operations, all the database operations that is to be performed using the software, all will come under the functional requirements. So that will be done in different manners. So there will be some function analysis. They will be performing some high level transaction specification. Though this high level transaction is actually the database retrieval, how to retrieve data, all those things will come under here. So they will be designing it separately. The software part will be designed separately. So from this data requirements, what you have to do is we have to create the conceptual schema. So using some high level data model. So we from the data requirements, we have to create the conceptual schema. So we have already seen what is a conceptual schema in the previous lectures. So you can refer the previous lecture if you want to see what is conceptual schema. So using some conceptual, this step is known as conceptual design. So from data requirements, we'll be creating a conceptual schema, which is a high level data model. This can be considered as a high level data model. So what we do is we'll draw some diagrams. So usually we'll be drawing the entity relationship diagram. So in this in this subject we will be learning about high level data model, that is the ER diagrams, entity relationship diagram. So from data requirements we will be drawing this entity relationship model, and this is a high level data model. This means this will be that ER diagrams will be understood by ordinary users. So that is a thing that is to be noted. This should be understood by the users of the software. So if you are drawing, if you are doing this conceptual design of a college automation software, we will represent this conceptual schema in some diagrams, and this diagrams will be given back to the customers or the users of the software for feedback, so that they will understand it and they will try to give feedback based on the conceptual schema. So they will say this is not, we have to add this more data to the database, we need this data to be stored, like that they will get feedback, and based on that feedback we will again refine this conceptual schema, and then it is again shown, like that it will be repeatedly done, and finally we will reach into a final conceptual schema. So this is a high level representation, and we will be learning about this high level representation or drawing the CR diagram in the next lecture, in the next lectures to follow. So from the conceptual schema, the next step. So these are all database independent parts. So this is a DBMS independent part. This falls under the DBMS independent part. So after doing all these things, next thing is to write the application program. So application program will be written by the software engineering team, and the database design team, what they do is from the conceptual schema, they have to map it to the logical or conceptual schema. It can be a conceptual schema based on the data model of the specific DBMS. So if we are using relational database, then we have to represent it in a relational database, a relational model. Or if we are using object oriented data model, then we will be representing it an object oriented data model. So this is a DBMS independent part, dependent part. So we will be mapping this, or we will be converting this conceptual schema into the logical or conceptual schema, so depending on the database. So this is known as logical design. So or we can call it as data model mapping. So we will be mapping the high level data model into a logical or conceptual schema. So this will form the database model. So we will be learning how to convert this ER diagram into tables or relations. We call it as relations. So in the syllabus, we have to learn all these things. So we will be learning the ER diagram, that is a conceptual schema, and from that ER diagram, we will be converting it into a logical, or we will be converting it into tables, relations. We call it as tables or relations, and uh, and then what we'll do is we will be doing the physical design, that is we have to convert this logical schema into the internal schema. So we have to represent it internally inside the secondary storage device. So all these things will form under the database design part, and parallelly we will be doing the software design part. So based on this function analysis, we will be getting the different types of retrievals that will be needed in the database, and based on that retrievals and update operations, we will be designing the physical design, and also this will be given to the application program, and the application program will be embedding all the commands to retrieve, and all the transactions will be implemented, and we will get the final application programs. So this is the basic design process. From mini world, we will start get the database. So we will be concentrating on this part of the design. So we will be mainly concentrating on this. So data requirements, we have to draw the, we have to represent it in conceptual schema. That is, we will be drawing ER diagram. Then from ER diagram, we will be converting it into the logical schema. That is, we will be representing it as tables. Then we will be representing that internal schema. That is how it will be stored internally. So these things will be dealing in this DBMS class. So this is the basic database design process. So throughout the lectures, we will be all the classes will be following the same example. That is a company example. So you should thoroughly understand this problem or the requirements of this company database. So I'll be explaining it briefly. The company, so this is the basic data requirement. The company is organized into departments, so there are different departments in the company, and each department has a unique name. So department has a unique name, and there will be a unique number to identify, and a particular employee who manages the department. So there will be a manager for the department also, and also we will keep track of the start date when that employee began managing the department. So start date of that manager will be kept. Then also a department may have several locations also. So in the company there will be, if we are taking a research and development department, so R&D department will be located in different locations. So there will be several locations for that company. For that department. So this is the first requirement. Then the second requirement, a department controls a number of projects. So in every department there will be a number of projects, and each project will have a unique name and a unique number will be there, and a particular project will be in a single location. So department will have several projects, but for each project will be located in a single location. Okay. Then another requirement is database will store each employee. So this is the employee details. So employee's name, social security number, address, salary, gender, sex, and birth date will be stored. Then an employee is assigned to one department. So an employee can work only for a particular department, but he may work on several projects. He can work on several projects which are not necessarily controlled by the same department. So a person will belong to a particular department, and he may work on several projects, and these projects may be controlled by different departments. Then it is required to keep track of the current number of hours per week that an employee works on each project. So that is also needed. So for each project that employee will be working. So if I am an employee and if I am working on 5 different projects, and for each project I'll be working for this many number of hours every week. So I have to keep track of that hours work per week also on each project, and also I have to mention the direct supervisor of each employee. So there is another employee who will be supervising a particular employee. So for me there will be a supervisor, for him there will be another supervisor, like that it will be a hierarchical manner. So I have to keep track of that supervisors also for each employee. Then the database will keep track of the dependents of each employee. So I may have dependents. So I may have wife or my spouse or my children. Like that, there will be several dependents for each employee. So this is kept for insurance purposes. So first name, dependents first name, sex, birth date, and relationship to the employee should be stored in the database. So these are the basic requirements of the company. So you should understand these requirements, because we will be using these requirements to represent into the high level schema, high level conceptual schema, that is the ER diagrams. So based on these requirements. So you have to understand. So in the next lectures and all, we will be using the same information for representing it in ER diagrams and all. So you should understand it thoroughly. Okay. So from this requirement, so next step is to draw this high level conceptual data model or the ER diagram. So we'll be learning about how to draw this ER diagram. So this is actually the ER diagram of this company example. So this is the actual example. So we'll be learning how to draw this in the next lectures that are to be followed. So this is the actual ER diagram. So if you represent the database part in the ER diagram for any applications. If you are developing a library management software, then you have to draw the same high-level conceptual data model. So this is easily understood. So any person can understand this, because if you see this is an employee, so these are the data that will be stored, like the department, and these are the data that will be stored. So you'll be learning how to draw this later. Or you can represent the same thing, high level conceptual data model, UML diagram also. There is your unified modeling language diagram is there. So this UML diagram can be used to develop the software as well as a database part. So this is the same thing represented in UML diagram. So you can either draw the CR diagram or UML diagram. In your syllabus, you have to learn only to draw the CR diagram. But when you design your softwares, when you go to some organization and all, you will be using this UML diagram mainly. But in your syllabus, we will be learning about this diagram. So next step on the in the next lectures to follow, we will be learning how to draw this ER diagram. So this is a reference. Thank you.